Before we get into the subject, I maybe wanted to share a story, a true story about how we started this whole journey. So I think it was the summer of 2024 when we were all sitting in a war room because of a network outage that had happened. And it was a complex problem to solve because it was caused by some packet drop issues. We had a number of Kubernetes clusters. Think about multiple sites, multiple nodes, master nodes, worker nodes, and we've got this situation where synchronization between the sites goes down, master nodes start going down, we have BNGs running on those clusters. At the same time, we've got a situation where link up and down cases are happening between the routers. So all these things are really, really hard to identify, to pinpoint, what's the root cause of the problem, right? So then all of this required us to go manually through lots of logs, trying to identify what might have been the issue, right? So then you start thinking, there should be a better way to address this situation. And what about these agents that people are talking about, right? And at the time, if you remember, and it feels like ages ago in 2024, but we had the very first iterations of these frameworks. We had LangChain, we had Crew AI, AutoGen, these things. But these things were intended to work for chatbots, for simple RAG pipelines, document chunking, maybe very basic SQL pipelines. It was not intended to be used for very complex network troubleshooting, and managing hundreds of Yang models and identifying very deep problems in networks, right? So then we started playing with these models, obviously, and at the time we didn't have reasoning models, right? So, but then you fast forward 18 months from where we were at the end of or Q3 of 24, and now we have a product, and I'll describe a bit of how it works. So we've come a long way in terms of understanding how we can best utilize the models and why the data is so important in this ecosystem, right? As you start building agents for managing networks, you realize that you need to spend a lot of time curating the data. Your data needs to be golden. Where's the best data and how the agents can utilize that data, right? So I'm going to cover a bit of concepts that were discussed already yesterday and today about what it means for networks, when we start seeing all these different types of workloads and flows now coming into the networks, right? And then I'll start getting into how do we do things today and how things could look like going forward with this new technology, right? So first of all, if we think about just at very high level in a architecture type of diagram, but thinking about how service providers participate in connecting enterprises to cloud providers, enterprises to hyperscalers, to neoscalers, to SaaS, and to AI model providers, right? We know that there's different types of flows and workloads that are running. One of them, it's been discussed this week, it's training, right? And training, it's about the front end and how data sets and weights get distributed to the different clusters, and that's a front end problem, a routing problem, load balancing across the GPU clusters. And then there's also the back end problem that was discussed, right? About the lossless requirement for the back end. But then on top of that, we add inferencing, right? And we know what that means in terms of low latency that's required and the burstiness of that flow pattern. And the third one that we know about is agentic, right? So now it's no longer about human-generated prompts. It's about machine-to-machine prompts. My OpenClaw agent, for example, I've got an OpenClaw agent hosted with 2 CPUs. Any prompt that I send, it's going to create API calls. I have it connected to maybe 7 or 8 Google Maps APIs, to my calendar, to my Gmail, to my thermostat, to my weather station. all these things are creating all these east-west transactions, right? So a lot of traffic flowing there, and as we see that trend where inferencing moves to the edge cloud, then we're going to see more and more north-south traffic. So what's really interesting is that if we think about a CapEx ratio of a front end and a back end being maybe 5-to-1, so spending 5 times more CapEx on the back end versus the front end, what truly happens with Agentic is that it explodes the front end traffic because of all this east-west traffic and all this API calling and MCP calling an A2A, right? So we have this situation where the networks that were built for broadband really cannot deliver the performance that's required for AI, really. So what do we do, right? And how are we fixing problems in today's networks? So situations that happen in networks with silent failures or maybe failures that are generating alarms, routing black holes, a network fails and we only realize when the SLA is breached and maybe the network is down, right? It requires a lot of manual troubleshooting, as we know. It's about going to all the nodes manually, scraping data. Not only logs, but think about a router with dozens of Yang models, and the technicians need to know where to go, what to extract, how to reason about it, make sense of it, and what to get next. In the chain of events, in a situation where you've got a topology of 20 routers and maybe you don't know where the failure happened, right? And it literally takes hours to troubleshoot these problems. As it relates to AI and GPUs, we all know that GPUs sitting idle cost a lot of money, right? So it's really something that we cannot afford. So it all becomes reactive, right? Where a problem is reported, gets investigated by the engineer, and then eventually something gets deployed. So the impact is huge in training clusters, hours of compute wasted, inferencing, the degradation of inference, it's really catastrophic because there's so many use cases where inference is very, very time sensitive. You can't really delay your response, the time to first token or the outputs, the consistent token outputs. So again, it's all about reactive operations that we see. So the conclusion here is that we cannot rely anymore on manual troubleshooting. Failures are really expensive in these types of networks, both for training and for inference degradation. So what is it that we really need? So from our perspective, we think that there's a few building blocks. We'll see that in detail. First of all, we need to think about an agentic framework that it's able to manage all of this and help us reason about what to do next. And then we're going to touch also on routing intelligence and why we think that connecting the agentic framework with enhanced intelligence on the router becomes super important for a self-healing autonomous network, right? So with this, we have this thought in Ciena about an agentic full stack to solve the network assurance problem, right? And we think in terms of 2 dimensions. We think in terms of network-wide troubleshooting, network-wide intelligence, combined with what's autonomous sub-second reflexes on the routers, right? So you might be familiar with TM Forum, and if you've seen it, you've seen the loops that TM Forum defines in terms of business operations, service operations, and resource operations as well. And the notion that we're familiar with, that we are extracting data from the nodes, we're extracting state, telemetry, alarms, and now controllers can reason about that data, right? They can observe that data, they can identify if there's issues happening, and then they can push policy and intent to the devices, right? And that's That's a loop that's very well understood and very well defined. It's a macro closed loop automation that's defined. To stir the pot a little bit, we know the protocols that we use these days, right? We know that we use heavily netconf from controllers to devices. But there could also be a better way to augment this. There could be a way to use MCP in a more distributed and flexible way, because there might be things from a router that we can extract and expose in the form of MCP tools. Things that may not be exposed today with netconf. Things that help us do forensics, postmortems, diagnostics. Even we could think about keeping netconf for specific use cases, and MCP, it's our next generation assurance protocol. Think about it in the world where we are today. What happens with APIs on the wire with MCP, right? Netconf is no different, is it? Right? It's a 20-year protocol. So, just some food for thought there. So think about this loop. It's a loop that happens in a time window of seconds to minutes, right? It's about planning, it's about optimization of the network, digital twin use cases. It's about assurance in the sense of being reactive, proactive, and predictive, but in a very well-defined time scale, right? In the scale of PCP, of maybe pushing new SR policies to the network, and remediation actions using a combination of netconf and MCP. And in order for this to work, we need to work with the models, with the protocol models that are defined at the node level, right? So everything that we support, for example, in the Ciena router, from interface level, coherent routing, rings, all the way up to service overlays, all of these things are modeled using Yang models today, right? So all that information needs to be known and understood by the agents, by the assurance agents that live in the Navigator node. And by the way, there's another session today about Navigator in the afternoon that I encourage you to attend as well, where the functions inside Navigator will be well defined. But we spent a lot of time with these models, with these Yang models, customizing them, turning them into a form factor that now the LLMs can use, that now the agents can best utilize to solve problems in the network, right? So that you realize very quickly that you spend most of your time dealing with the data. And it's about what the agent has access to. It has access to the Yang models. It may have access to best current practices. It may have access to the specs and internal documentation that will help the agent. So that becomes super critical. And then the very last thing that I wanted to touch on here is what I call the micro CLA. And the reality of things is that protocols see black and white, but networks fail in shades of gray. They do, because link up, link down situations, or rerouting, or BGP established, or idle, protocols are great with that. What they're not great with is latency increasing and trending in the wrong direction, jittery situations, intermittent flaps, ECMP imbalances. There's lots of situations where you would need another level of intelligence in the node that could help with those cases. And that's what I call micro CLA. And there are multiple use cases in different areas: assisting with routing protocols, assisting with flow control situations and QoS, and assisting with security situations, right? This may require agents on the box, as well as some level of peer coordination across these agents, right? So I'm going to show you a use case that we are demonstrating actually in our booth. So we've got a DCI use case with routers on both ends, and I'll run quickly through this. Really, what we did is that we simulated a misconfiguration of causing a silent failure. So essentially a default route that's misconfigured. So this agents, and in particular one of the agents that has subagents, understands the topology of the network based on the prompt that was given, understands the scope, understands the active alarms, analyzes fully end-to-end control plane and the protocol stack on every single hop, detects the missing route. It could be a missing route, it could be a route that has been retracted for some other reason, it could be a bug, it could be anything really. And then it provides a root cause analysis, configuration, remediation to the user, to the human. It doesn't act upon the router, so it just provides guidance. This is what you should be doing to fix the problem, right? So yeah, we have that in our booth. If you'd like to come over, we can explain how that works in detail and how we've implemented it. And just to finalize, what's the opportunity to monetize AI transfer for service providers? So first of all, it's about SLAs. It's about the creation of an AI transport tier that service providers can monetize, as well as creating customer stickiness through critical workloads and becoming the regional provider to connect enterprises to AI fabrics, differentiating through multi-tier SLAs. We saw how bringing assurance and AI ops into the network really reduces the median time to repair from hours to minutes. We've proven that with customers. And then getting into proactive operations, not waiting until a problem happens, but being able to identify an issue before the SLA is breached, right? And finally, what we're very focused on is Ciena devices, as well as integrating multi-vendor, because we know that issues happen across different vendors. The final thought about this is that to monetize AI transfer, we need to think about reliability as a service in the service provider network. Okay, so with that, thank you so much.